In this lecture, we shall see what is median of a given data set, median of ungrouped data, median of grouped data, and some examples. What is median? Median of any distribution is that value that divides the distribution into two equal parts such that the number of observations above it is equal to the number of observations below it. Thus, the median is called the central value of any given data, either grouped or ungrouped. Median of ungrouped data. First of all, we need to arrange the data set in ascending or descending order. If the total number of observations is n, then there are two cases. Case 1, n is odd. When n is odd, the median will be value of the observation at n plus 1 divided by 2 in that position. We take an example. If the observations are given by this, then find the median. First of all, we need to arrange the data set in ascending or descending order. We have arranged it in ascending order. Here n is equal to 9, which is odd. So median will be 5th position, first position, second position, third position, fourth position, fifth position. So the median is 27. Case 2, n is even. In that case, median is arithmetic mean of values of observation at n by 2 and n by 2 plus 1 position. In this example, the observations are given. We need to find the median. First of all, we need to arrange the data set in ascending order. And we note that here n is equal to 10, which is even. Then median will be arithmetic mean of the values at 5th and 6th position. That is, the arithmetic mean of 25 and 27, that is 26. Median of group data. This is the formula to find median of group data, where L is the lower limit of median class. We shall see in the next slide what is median class. N is the total number of observations. CF is the cumulative frequency of the preceding class. F is frequency of median class and H is class size. In this example, class interval and frequency are given. Now we create this table. Here class interval and frequency are given and we find cumulative frequency. In the first position, that is 6, and then we add 6 and 11, we get 17. After that we add 17 and 13, we get 30. Then we add 30 and 6, that is 36, and finally we add 36 plus 4, that is 40. Here n equal to 40 and n by 2 equal to 20. Now we need to see this in which interval 20 lies. In this table you see the cumulative frequency is 17 when the class interval is 20 to 30, and after that we get the cumulative frequency 30 in the interval 30 to 40. Now note that the 20, the cumulative frequency 20 lies in this interval 30 to 40. So that's why 30 to 40 is the median class. Here the lower limit is 30, L equal to 30, and CF is 17. What is CF? CF is the cumulative frequency of the preceding median class, that is 17. F is the frequency of median class, that is 13, and H is class size, that is 10. Now we use the formula to find the median. L plus n by 2 minus Cf divided by F multiply with H. Here L is 30, n by 2 is 20, minus 17, that is cumulative frequency of the preceding median class, that is 17, divided by F, so divided by 13, multiply with class size, that is 10. So we get 32.31. So the median value for this data set is 32.31. The median is good measure of central tendency when data set is skewed or there are extreme values or outliers in the data set. Now we shall see what is mode of a given data set, mode of ungrouped data, mode of grouped data, and some examples. Mode is the highest frequency observation of a given data set. Now a data set can have more than one mode, as there can be two observations with same number of highest frequencies. Mode of ungrouped data. The mode of ungrouped data can be simply calculated by observing the observation with the highest frequencies. In this example, we see the frequency of 5 is 2 and frequency of 2 is 2 and the frequency of other element is 1. So, the mode of this ungrouped data is 5 and 2. Mode of group data. We use this formula to find the mode of group data. Here L, that is the lower limit of the modal class. What is modal class? Modal class actually contains the highest frequency. H is the class size, F1 is the frequency of modal class, F0 is the frequency of class which precedes the modal class, and F2 is the frequency of class which succeeds the modal class. In this example, class interval and frequency are given. We need to find the mode. You note that the class interval 40 to 50 contains the highest frequency, that in 15. So, that is our F1, and the preceding class interval is 30 to 40. So, 13, that is F0, and the succeeding class interval is 50 to 60. So, 10 is F2. Here we note L equal to 40, the lower limit of modal class, and the size of class interval is H, that is 10. Now we put these values in this formula. Thus we get the mode of the data set is 42.86. The mode is a good measure of central tendency when there are clear peaks. That means there exists a large frequency of a particular element or particular class interval compared to other element or other class interval. There is a relation between measure of central tendency, that is 2 into mean plus mode equal to 3 into median. This formula we can use to calculate any one of the central tendencies when we know the other two central tendencies.